Hey everybody, I'm Alex, and today we're going to be making some cross-country trophies. Um, my brother is somewhat of an assistant coach at a local high school that his daughter, my niece, runs for the cross-country team. And he has asked me if I could make some trophies for the end of the year sports banquet that they have. This is actually a trophy that he designed um, back when I was running cross country in high school. My brother's 9 years older than me, so he was my coach going through school. So running is important to me, and I guess making this award's kind of like carrying on the legacy a little bit. So I'm excited to do this. What the spike is, or what the trophy is we're going to be making a spike, and in cross country, runners wear shoes, and on the bottoms of the shoes they have spikes, metal spikes that help them gain traction in muddy conditions, to ultimately help them run faster and more efficient. So just to take a look at what the shoes are designed, it's the bottom of the foot has a spike plate, and on the spike plate you screw in metal spikes. The spikes themselves, they come in all different sizes, or different lengths. I think the longest might be like half inch. I don't think I've ever seen any longer than a half inch, other than the one that we're going to make today. So, but yeah, pretty basic. But just taking a look at the spike, you'll notice how there are flats on either side of the spike, and those flats are there so you can use a wrench to screw them tight into your shoe. So we're going to use that flat to do our etching, our laser engraving on, to put the kids' names and what the award is for. And we're actually on the back side, because there's a flat on either side of the spike. On the back side, we're gonna put the logo of the school, or the school mascot, and write cross country underneath of it. So let's take a look at the spike. So in Mastercam, and if you're familiar with Mastercam, you'll see I've already applied all the toolpaths, but really just wanted to take you into Mastercam here to show you what this process is going to look like, and just give you a couple, some ideas of what my workflow looks like inside of Mastercam. So to start off, taking a look at my level manager, on level 1 I have the spike itself, which is my 3D model of the spike. We didn't draw the threads into the backside. We will machine them, so they will be there. But really, for programming purposes, it's nice to... It's just easier to not have the threads drawn on the model. So in this case, we just drew the major diameter, just to give us an idea of what that biggest diameter will look like on the threads. So on level 2, I have my stock wire, and on level 3, I have the stock solid. And what you can see back here in the blue, that's a representation of the jaws that'll be holding the stock. So this is not entirely accurate, because I would never try to hold apart by that little tiny bit without having like a center, a tailstock engaged in the side of this thing. But this stock I'm actually buying, I think it's going to be 3-foot bars, so the material will be back far into the draw tube, and it'll be fed throughout the front, so they'll have full engagement on these jaws here. But this is, just for programming reasons, this is, that's my stock. Moving down to level 10, What I like to do in Mastercam is I like to separate out my operations with, I call them divider levels. So in this case, level 10 is just labeled op 1. It has 0 entities on that. But underneath on levels 11 and 12, I have everything that's associated to operation 1. So if I need to jump in and make a change, I can jump right into Mastercam and I can find that geometry that I used for programming. And then so level 20, same thing, a divider level, and then underneath of level 20, I'll have all of my operation 2 stuff. And, if I had an op 3, that would probably be level 30 with another divider level, and everything under that would be associated op 3, and so on. So, taking a look at this process, we'll be making this part in a mill turn. It'll be a Mori Seiki MT2000. So we have that ability to turn the part and mill the part in one operation. So that is great, not just for the reason that you can process parts faster and quicker, but the nice thing about these machines is you can do more at once, which ultimately results in a more accurate part, due to you being able to machine more things in one operation. So, taking us into the toolpaths, the first toolpath that I have here is we're going to run a rough turn on this diameter here. So that's going to turn in and rough that shape in. Operation 2 will come down and not operation 2, I'm sorry, toolpath 2 will come in and we'll finish that diameter. Toolpath 3 will machine the flats. Toolpath 4 will finish the flats. So we have rough the flats and finish the flats. And toolpath 5 will be this back turn here. So an OD groove. And toolpath number 6 will part it off. Now when I part this thing off, I don't want this part to fly into the bottom of the machine. And this part, or this machine, does not have a parts catcher. So if we were to part it off without getting creative and like putting a box on the lower turret or something like that, this would end up falling into the bottom of the machine and could end up denting the trophy. So what I'll do is I'll part this off. So we'll leave a little bit attached to the raw stock, and then we'll just be able to break this part off with our hands. Kind of reminds me of the old Ninja Turtle toys, when you would buy a Ninja Turtle and it would come with all the weapons, and you would have to break the weapons out of the plastic that it was surrounded by the little tabs. So that's what we're doing. We're leaving a little tab on it that will hold the spike onto the material. Alright, so after Operation 1 is completed, what we'll have is we'll have the part with flats on either side. Let me explain that real quick. So you may have noticed that when I programmed the flats, I only programmed the flats on one side of the part. Since the part is symmetrical and the flat on the other side is the exact same, what I'll do is I'll make these toolpaths here a sub-program, and in the main program I'll have it just rotate the C-axis 180 degrees after it runs the first set of flats, the first flat. So I have found that to be the best solution for this machine that has very little memory. Is program, if you have a symmetrical part, program as much as you can, and then make that high G code or heavy G code file be its own program, and then in their main program just rotate the C as many times around as you need to. So that's how I'm going to solve that problem. This machine has very little memory. So after the part is finished operation 1, we'll go down to operation 2, and if you can imagine, the part will have the little piece that could possibly have that little piece that's broken off. Another thing that I should have pointed out is when I parted this off, go back to here, when I parted this part off, I left 10 thousandths of material on the back face. And the reason that I did that was so when I go to do the next operation, I can just take a skim cut and make that just look perfect. Have an issue sometimes where part off blades just won't leave that perfect finish that you're looking for without some tweaking, and I just kind of want to get this thing going and roll with it. The other thing is this area here, which we call the tit, that will be a bit of a problem. I have to either file that off, and I don't want these to have any rock to it, to them. So what I've decided is just in the next operation, I'll skim that face to make it perfectly flat and put my thread on, and put a nice chamfer on the end, so I don't want this thing being sharp at all. So moving on to that second operation, to give you an idea what the setup is going to look like, we're going to do this in a horizontal machine, and the setup is going to look like this. So if we're on our pallet, the pallet will rotate to minus 90 degrees, and at that point the face mill can come in, face the end of the part, thread mill, and this is actually going to be an M40 by 2 thread, but this thread doesn't actually have to screw on anything, obviously, so I'm gonna comp that out some because I don't want that sharp thread point on there. I actually want this to be a very dull, inaccurate thread. And then the last thing that'll happen is we'll run a nice chamfer around the whole part, and that'll be it. So yeah, check it out. Here's what the first operation looks like in the machine. So that was Operation 1 that you just watched, and I meant to film Operation 2 the exact same way, because this is a job shop and I'm just constantly trying to get things done. Didn't stop the thing to film it before I ran out all the parts. However, I realized it when the last part was still loaded inside of the machine. So here is what that looks like, what that program looks like running in the machine on a part that's already been cut. Good thing is I don't have to run coolant because the part's already been cut. So check it out. So what I've done is I set up like a load position in the machine, an easy spot to be able to reach and load the part. You can see that the way that the machine is set up, it would take a while for the pallet to pallet change out and come all the way over to the workstation just to load the part. So since we're just doing a couple parts, I just left it inside of the machine and set a load position. So the Z comes up to here, and we're able to unclamp the vise, put the part in, and then cycle start. So here we go. So there you go, that's the award. It is completely machined, so it'll go on to the next step, which is the laser, to get laser marked with the different kids' names and why and for what it is. We're pretty new at YouTube, so I just wanted to take a second and just kind of show our capabilities back here and some really cool stuff that I think you can expect in the future. We have a lot of really good, a lot of technology in this shop, and I'm really excited to do more mill-turn parts and do some more horizontal stuff. I mean, just having these two machines sitting here, you can really do, which is a, again, it's a Mori Seiki MT2000. And this is a Matsuura H Plus 300, and just we have a ton of capability with these two machines, and yeah, so a lot of stuff to come, and just get excited.